welcome you to organic chemistry. Today we are going to see one chapter called aldehydes and ketones. Actually both these compounds are come under the compounds containing C double bond O. This functional group is called carbonyl group. Carbonyl compounds. All these compounds which contain C double bond O is known as carbonyl compounds. Now these carbonyl compounds are divided into the two types. A carbonyl group containing a minimum of one hydrogen. One side hydrogen should be there. The other side we have an option. The other side option is there. The option is it can be a hydrogen, it can be any alkyl group, or it can be any aromatic group also. It can be a hydrogen or the alkyl group or hydrogen. Whereas a carbonyl compound group containing no hydrogen. No hydrogen means both the sides either hydrogens or one side hydrogen and one side alkyl group, or one side hydrogen, one side some aromatic group, or both the sides alkyl groups, or both the sides the aryl group. The hydrogen should not be there. This hydrogen, if it is there, we are calling as a aldehyde. Therefore, alkyl group, two alkyl groups, or one alkyl, one aromatic, or two aromatic is known as a ketone. Here one hydrogen is allowed. Either both the side hydrogens, or one alkyl, one hydrogen, or one aromatic, one hydrogen is known as aldehydes. Some simple examples let us see. A carbonyl group containing one hydrogen and another side also hydrogen is known as, actually systematically known as one carbon, methanal, methanol. This Al is the root word, that is coding system for the aldehyde. However, it is known as what? Acetaldehyde, the formaldehyde. This compound is known as formaldehyde. One carbonyl compound is known as formaldehyde. Formaldehyde. A carbonyl compound containing one side hydrogen, the other side smallest alkyl group, let us take one carbon. Now this is called two carbon aldehyde, is known as ethanol. Ethanol is also known as acet. This CH3CO is known as acet. Therefore, it is known as acetaldehyde. Acetaldehyde. Okay. Now the another example, one hydrogen, one side if benzene is there. Benzene attached aldehyde is known as benzaldehyde. Benzaldehyde. In aromatic system, the IUPAC will not entertain the exact nomenclature, but however it may be called as a phenyl containing methanol. Phenyl methanol may be the IUPAC name, but everybody uses benzaldehyde. IUPAC allows also. Now coming to the ketone side, the smallest ketone is CH3 C double bond O CH3. That is, no hydrogen should be there each side, both the sides. But alkyl groups are allowed. Smallest alkyl groups are methyl. This is called 3 carbon one, therefore systematically called propanone. Propanone. Okay. This CH3CO group is called acet. Is called commonly acet. Acet with hydrogen is the acetaldehyde. Acet with one alkyl making a ketone is commonly known as acetone. Acet stands for the CH3CO function. Acet with the ketone, smallest ketone, is okay, possible first ketone is acetone. Then another type is again acet is there, but the other side if you have a benzene ring, okay, then it is called acet phenyl plus one. Somebody called it as a acetophenone. Acetophenone. Some logic is there also. Acet is there, phenyl is there, plus a ketone, acetophenone. Acetophenone. Acet plus phen plus one, acetophenone. However, in the systematically you may call phenyl ethanone. Two carbon ketone is ethanone. Phenyl group phenyl ethanone. But everybody says it is a acetophenone. If both the sides benzenes are there, It is also a ketone containing both the sides benzenes are there. Benz with CO is called benzo. So, therefore, it is called benzophenone. Benzophenone. So, three ketones are very much popularly known: formaldehyde, acetaldehyde, benzaldehyde. These three aldehyde. If one more carbon is there, propanaldehyde, butanaldehyde, pentanaldehyde, long chain. As the number of carbons increases, you can say the common names of propanaldehyde, propienaldehyde actually, but you can say propanaldehyde. Here the ketones also, three ketones are very popular: propanone, acetophenone and benzophenone. But most of our discussion will be based on the acetaldehyde and the acetone. These are the two typical examples are given for the study of the aldehydes and the ketones. Preparations, properties with reference to this the acetaldehyde and acetone we are going to see. Now, let us see how these the acetaldehyde and acetone are in general aldehydes and ketones are prepared. Preparations, let us now take up. Preparation methods. There are huge number of preparation methods are there. However, it is not possible to cover all the methods. The important methods we will take here. The first one is oxidation of alcohols. Oxidation of alcohols. In this method, aldehydes can be readily prepared by taking the 1 degree alcohols. If you take these alcohols by oxidation method, the hydrogen and the hydrogen can be dropped and you are able to prepare the aldehydes. So, acetaldehyde may be prepared by taking this one. Here you may use a mild oxidizing agent like dichromate or permanganate. With a dilute condition, if you use, you will get it. Otherwise, it will oxidize to acid. So, for the preparation of acid, you can take dichromate, permanganate in acidic medium, you will get the carboxylic acid. To stop this, the reaction, actually a copper at 300 degrees is very much suitable. If this is used, this nascent oxygen problem will not be there and you will get these hydrogens will be expelled as H2. If you want to use oxidizing agent, it should be very much controlled. So, you can use one pyridine with HCl and chromium trioxide. This complex is known as PCC. Pyridinium chlorochromate, pyridinium chlorochromate. It can be prepared by adding the HCl to the pyridine. You will get a pyridinium chloride. After adding the chromium trioxide, you will get this chromate. This oxidizes the nascent hydrogens will be dropped and you will get this the acetaldehyde preparation. This should be a controlled, otherwise you will get a acid. Similar the way, if the 2-propanol, if it is oxidized, you are going to get a acetone. Same method. Either the PCC or the copper 300. If you use, the hydrogens are removed and you are going to get the acetone preparation. So, acetone and acetaldehyde both can be prepared. Both are controlled oxidation, especially in the case of aldehyde. If you use pyridine, that is pyridine chlorochromate, this is known as PCC, a reagent which controls the oxidation of the 1 degree alcohols into the aldehydes. In the case of ketones, you need not too much worry. You can use a copper 300 or dilute sulfuric acid. In the case of dichromate or permanganate also can be used. The second methods are hydrolysis of 1,1-dihalo compounds, 1,1-dihaloalkanes. An alkane containing 2 halogens on the same carbon like this. Okay. If you use aqueous sodium hydroxide, both the Cls will be replaced by the OH group. So, initially what you will get is a dihydroxy compound will come. However, the 2 OHs on the same carbon is not stable. So, immediately a loss of water molecule will finally gives the acetaldehyde. Similar case, you can also use it on the, if the chlorines are on the middle carbon, then naturally the similar reaction will give a 2 OHs on the middle carbon. 2 OHs means eliminate the water. So, what you will get is a acetone preparation. So, now let us see the 1,1-dichloroethane, if it is taken, you will get acetaldehyde. If it is from this side, it is 2,2-dichloro. Though it is 2,2-dichloro, we call 1,1 because the first chlorine containing carbon, again it is having one more chlorine. Therefore, nomenclature purpose is called 1,1-dihalo or geminal dihalo. That means both the halogens are on the same carbon. This gem type of the dihalo compounds and hydrolysis will give the carbonyl compounds. Third method is hydration of alkynes. Hydration of alkynes. Alkynes contain a triple bond. A simple example is if you take acetylene and add the water. Actually, the water addition, even in the case of ethylene, is a failure reaction, but catalyzed by sulfuric acid, it is successful. Here also around 40% sulfuric acid will be taken and 1% mercuric sulfate. 2 catalysts are required. Sulfuric acid dilute means water plus sulfur, or if you write water, you can write water separately, concentrated sulfuric acid small quantity and mercuric sulfate. The reaction is catalyzed by this sulfuric acid concentrated and mercuric sulfate will, now the HOH will be added. What you will get is a enol is formed, which this is a vinyl alcohol or ethanol. Ethanol undergoes a tautomerism. Ethanol undergoes a tautomerism and this compound is going to give the acetaldehyde. So, finally, what we are preparing is acetaldehyde from the alkyne. The reaction is called hydration reaction or addition of water to the alkynes. However, this reaction you can also take up for the preparation of the acetone also you can. Acetone means you want 3 carbons. So, therefore, 3 carbon containing alkyne you take. Add the same reaction, that is addition of water in presence of concentrated sulfuric acid and the mercuric sulfate. 2 catalysts are there, addition of water taking place, the HOH is added here. You have a Markovnikov rule application here. The OH minus is added where hydrogens are less. This side 1 hydrogen, this side 3 hydrogens are there. Middle carbon is not having the no hydrogen. So, OH goes to the less carbon side, H goes to the more hydrogen side. So, therefore, OH goes to the hydrogen less carbon, that is middle carbon. So, therefore, what you will get is a OH will be coming into the middle carbon, which on tautomerization leads to give this the acetone. That is H goes there, the double bond goes that side, hydrogen is shifted to the terminal carbon, you will get the acetone preparation, propanone or acetone by taking the propine. Same reaction, this is also nothing but the hydration of acetylene gives acetaldehyde, hydration of the propine gives the acetone. This is the third method. In the fourth method, we are going to prepare the compounds from the carboxylic acids. An acetic acid, calcium salt you take. Calcium salt acetic acid means O minus will be there. Another acetic acid also links to the calcium acetate, it is known as COO minus calcium acetate, it is known as calcium acetate. Acetic acid, calcium salt you take, it is a solid, calcium acetate is a solid. Take this solid, go on heat it. Merry heating without putting any reagent, if you just go on heat it, compound undergoes a breakage. In fact, calcium carbonate is formed. The CH3CO and the CH3 joins up, you will get the acetone formation. So, method is useful for the ketones preparation. Whatever the long chain you will get, this side that side chains will be there, a ketone will be formed. In the flask, calcium carbonate will be left over. So, this will be distilled out as because it has got lower boiling point, the ketone will be coming. The same calcium acetate, if you instead of heating, you take some the formic acid salt also. formic acid taken twice calcium, this is known as calcium formate. Take calcium acetate but mix the calcium formate, the mixture is heated. The mere heating without putting any reagent is known as pyrolysis. Pyro means temperature, nolysis means breakage, pyrolysis. So, pyrolysis of calcium salt will give acetone. Pyrolysis of calcium salt with calcium formate, in addition with the calcium formate, you will get the acetaldehyde will be the resultant product. It works as a reducing agent, therefore acetaldehyde will come. So, this method will give the acetone as well as acetaldehyde, but remember, alone calcium acetate on pyrolysis will give acetone. Calcium acetate plus calcium formate together you will get the formaldehyde. We are having one or two specific methods also, like there is one method called Rosenmund reduction. Rosenmund reduction is the name reaction, very popular reaction, asked 3-4 times in the EAMCET examination also. This is nothing but a reduction of acetic acid chloride, acetyl chloride. This is known as acetyl chloride. Acetyl chloride, when you reduce with a lithium aluminum hydride, it gives the ethanol, but we want aldehyde. Okay, so for which you are taking hydrogen gas and palladium adsorbed over the barium sulfate in a quinoline solvent. This mixture of this palladium, barium sulfate and all that is known also as a Lindlar's catalyst. Lindlar's catalyst. The same catalyst is used for the reduction of alkynes to controlled reduction to get alkenes. The same Lindlar's catalyst with acetyl chloride with hydrogen, this reduction takes place and you will get the CH3CO, H is coming. This is called what? Acetaldehyde. Acet plus aldehyde, acetaldehyde or ethanol. Okay, this controlled reduction is known as Rosenmund reduction. What is used? Acetic acid, acid chloride. This is, therefore it is called acetyl chloride or ethanoyl chloride. Systematic nomenclature is ethanoyl chloride reduced with hydrogen in presence of the specific catalyst palladium adsorbed over barium sulfate in quinoline solvent. It gives acetaldehyde, right? So these are the specific methods we have, and some oxidation method like this is also mentioned in some books like Waker's process. Waker's process. 1 or 2 times the question has come in the Waker process also. Alkenes like ethylene on oxidation with half a mole of O2. Actual reagent is half a mole of O2. With this you are getting a acetaldehyde. But it is not simply just passing the half a mole of the oxygen. You need a palladium catalyst and a copper chloride catalyst and water. All these three are working as a catalyst. Okay, palladium chloride or palladium with the copper chloride and the water. All these three works as a catalyst. In this catalyst, 3 catalysts, you are getting this half O is adjusted here. It's a balanced equation. So you are getting a acetaldehyde. This is a commercial process. If alkene is propene, then you are able to get the propanone also. So the method is applicable for the acetaldehyde as well as acetone also. So now let us go for the second part of the aldehydes and ketones, that is properties of the aldehydes and ketones. Properties of aldehydes and ketones. the chapter happens to be a middle of the different other chapters, and huge number of questions are coming from the properties of aldehydes and the ketones. Even preparations also many are there, but fortunately we have for the EAMCET syllabus we have very few limited methods are there. As I said, 6 methods preparations. If you are thorough, I think you can do the questions. Now the properties, however, we have huge number of properties are there, so we have to cut short here and there, but still the coverage let us try. The first property is nucleophilic addition reactions. Nucleophilic addition reactions. This is the most important reaction. It can be summed up like that. If I add a AB reagent, A plus B minus, let us think. The carbonyl group always will be in the equilibrium with C plus and the O minus structure. This is not a resonance, this is a polar structure, this is a double bond. Now the A plus and B minus both are ready to attack on the A plus on the O minus, B minus on the plus, but the C plus is having 6 electrons, that is not having the octet and a electronegative element holding the positive charge. Therefore, first B minus will attack. So B minus happens to be a nucleophile, therefore it is called as what? The first step. This is what actually step 1. Okay, first step is a nucleophile step, therefore first a nucleophile starting, therefore it is called nucleophilic addition. However, O minus later receives the A plus. The 2-step process. First nucleophile is added, then electrophile is added. Finally, what happens? O gets A plus and B minus is added on the directly to the carbon. This type of reactions we have huge number of the different types of examples we have. Now let us take one simple example for this category. Addition of HCN. Addition of HCN. H is the plus, cyanide is the minus. So if you take acetaldehyde, what happens? Let us see. Acetaldehyde adds HCN. H plus is added on the O and cyanide minus is added on the carbon. So therefore what you will get is O will become OH, a cyanide is added. Cyanide contains a triple bond. This cyanide undergoes a hydrolysis in the next stage. If the preparation is over, in fact this property is completed, it is a nucleophilic addition. But this the hydroxy group containing cyanides have some application is there. This application is you just do hydrolysis, see what is going to form. You are going to get a carboxylic acid containing a OH. Where is that OH? On the second carbon. This carbon is called alpha. So alpha hydroxy acid, specially from acetaldehyde starting, you have prepared this alpha hydroxy acid is called lactic acid. Biologically very important acid, lactic acid is able to be prepared. So first we have added a HCN following nucleophilic addition mechanism. After that, if this HCN added, that is cyanide containing compound, on acidic hydrolysis or acid catalyzed hydrolysis gives the lact. Similarly, different types of the compounds give the different types of this carboxylic acids. Then the second method, let us see. Addition of the RMGX. This we have also seen in the aldehydes and ketones, that is carboxylic acids preparations also. So now let us take a formaldehyde or acetaldehyde. Okay, acetaldehyde, let us see, and what happens with a suitable example like methyl magnesium chloride. If you take, what happens? The methyl is the minus and magnesium is the plus. So which group will be first attacking? Minus party will be added first, followed by the magnesium. So you will get a salt formation. The salt is nothing but the 2 carbon with 1 methyl added, methyl also here, and the O minus with methyl, the halide or the chloride. This on acidified acidification becomes into a 2 methyls and 1 hydrogen containing alcohol. This is nothing but the 2-propanol. 2-propanol. So 2-propanol or isopropyl alcohol is formed. So here this is the methyl is the minus party, adds carbon, magnesium adds on O, a salt. This is nothing but the 2-propanol magnesium chloride salt is formed, which on acidification you got the 2-propanol. Okay, right. Now similar the case, if you take a acetone, what happens? If you take acetone, example 1 is with acetaldehyde we have taken. Another example let us take with acetone. Acetone has 2 methyl groups, okay, and then we are adding a one more methyl containing magnesium chloride. If I add, the methyl adds on this carbon, already 2 with this 3 methyls containing alcohol is going to form. However, in between you will get a salt. The salt on hydrolysis or with the H3O plus you can write becomes into an alcohol which is containing a 3 methyl groups. This is known as a tertiary alcohol, and its name also tertiary butyl alcohol. Common name is there. Tertiary butyl alcohol can be prepared from the acetone plus adding the methyl. You can add variety of the alkyl magnesium chlorides. These 2 groups can be also goes on changing. If A and B you have taken, C another alkyl group. Finally A, B, C, 3 different varieties of alkyl groups containing alcohols also can be prepared. If you take formaldehyde, in fact you will get the 1 degree type of alcohols, but our aim is what happens something if you do on the acetaldehyde, what happens if something if you do on the acetone. Both the questions, previous question papers, if you see the acetone with the methyl magnesium chloride followed by hydrolysis, which of the following compound is formed? This is the tertiary butyl alcohol is formed once this question was asked. Now let us go to the few more the questions like sodium bisulfite also can be added. Sodium bisulfite, when you, this is a solid actually dissolved in water, aqueous solution is prepared, but you should have a saturated aqueous solution. Saturated aqueous solution. You take the saturated aqueous solution. The purpose is here, this compound, if you add water, it dissolves. Go on, add till the no more solid is dissolved. That contains shows a saturated state. That saturated aqueous solution, you take it, add it to the carbonyl compounds like acetone or acetaldehyde, any compound if you add, what happens, this compound is going to added here, and acetone requires the sulfate anion. O will become a OH here, and SO3 minus a sodium salt of the sulfate is formed, which is a precipitate, white crystalline precipitate is formed. It works as a test therefore. So how do you identify a carbonyl compound? Means all carbonyl compound, a few drops of this the compound, if you add it to the liquid acetone, immediately you will get a white crystalline color precipitate. It works as a test. The other than this aldehydes and ketones like carboxylic acid, alcohols, all other compounds will not give this type of the precipitation or the white crystalline the product formation you don't observe. Only in the case of the carbonyl compounds, aldehydes and ketones, both gives this reaction. There is no discrimination between this one. Corresponding compound is formed. But addition, it is a nucleophilic addition, once again reaction taking place, right? You can add water, you can add ammonia, you can add alcohol. With alcohol, hemiacetal, acetals are formed. With water, hydrated products are coming. So huge number of nucleophilic addition reactions are there. But let us go for the second type of reactions are called condensation reactions. Condensation reactions. The condensation reactions are like this. A compound containing 2 hydrogens on ammonia containing a Y group. If you add, what is happening, the O and the H2 together is eliminated as a minus of H2O. Actually what is happening is this ammonia as a nucleophile attacks here and the hydrogen is shifted to nucleophilic addition. The OH and H eliminates back water and this N, C and N will become a double bond. A carbonyl compound will get this N and the Y. These products are called condensed product because water is eliminated from the two different compounds. If water is removed, dehydration, condensation refers to the formation of water here. So, if the water is removed, it is called a condensation reaction. Let us take a carbonyl compound like acetone. What happens? If acetone is taken, the first example is NH2 with OH. That is, if the Y group is OH, the reagent is called hydroxy ammonia, is called hydroxylamine. Remember, what is this? OH containing ammonia, that is in the place of Y, we have taken a OH, that's all. OH containing ammonia is called hydroxylamine. If hydroxylamine is added, this H2O goes, this is nothing but the acetone. Okay, acetone with hydroxylamine gives a compound known as acetone oxime. The products are called, you have to write the name, total name of the compound, acetone plus oxime. So, the question can be asked, which of the following compound gives oximes? Carbonyl compounds will give, no other compound will give. With the carbonyl compound, aldehydes and ketone, which reagent will give the oxime? Hydroxylamine will give the oxime. Similar the case, acetaldehyde also will give the similar reaction. Acetaldehyde is nothing but the 1-methyl, 1 hydrogen. Similar reagent will give 1-methyl, 1 hydrogen with a double bond NOH. This is known as acetaldehyde oxime. Acetaldoxime or acetaldehyde oxime. You can say total name acetaldehyde oxime or acetaldoxime. So, both the compounds are going to give this reagent, that is, let us say A reagent is known as hydroxylamine. Let us go for the another reagent. The reagent, if it is NH2, NH2. That means a ammonia containing ammonia. When you add a carbonyl compound is undergoing once again a condensation with this H2 and O is eliminated and the product is known as now an acetone with NNH2. NNH2. This name is, this part of the compound is acetone. Acetone with a reagent name is hydrazine. Reagent is hydrazine. Remember the reagent name as well as the reagent with the X compound gives acetone, the hydrazone, acetone, hydrazone. Hydrazine, Z-I-N-E will become Z-O-N-E, hydrazone. Hydrazone. The difference is only the O. Okay, this is acetone. Acetone plus hydrazine gives acetone hydrazone. The product name is acetone hydrazone. What we have taken is, it's nothing but a ammonia containing another ammonia. Ammonia in ammonia. This is water containing ammonia, hydroxylamine, hydrazine. Now, another reagent is, if the acetone is treated with ammonia containing a NH with a benzene, this is known as phenylhydrazine. This is known as phenyl, up to this one is hydrazine with a phenyl. So, therefore, it is known as phenylhydrazine. Phenylhydrazine. What comes here? You will get a acetone phenylhydrazone. Acetone, phenylhydrazone. A phenyl will be there, NH will be there. Acetone phenylhydrazone. Ending will be Z-O-N-E. Same X and Y. Its name followed by the reagent name, and in the reagent name I will be replaced with the O. So, therefore, if acetone is taken, acetone phenylhydrazone will be the product. Only thing is, you have to take care the O from the carbonyl compound, H2 from the ammonia compound is removed as a water and the derivative is called. All these compounds, oximes, hydrazones, phenyl hydrogens are white color crystalline compound. Therefore, the moment you add this reagents, you are getting the white color the derivatives. Therefore, they are also A, B, C also can be used for the identification of aldehydes and the ketone. Both will give. It is not differentiation between aldehyde ketone, but it is identification. We have two more reagent. If the reagent is ammonia containing ammonia with a benzene, that is phenyl ring. In the phenyl, we have two nitro groups also. Two nitro groups. Where are they? On the second carbon and on the fourth carbon. Therefore, this is known as 2,4-dinitro phenyl hydrazine. This is hydrazine. It is having a common name also, 2,4-DNP. Stands for what? 2,4-dinitrophenylhydrazine. Okay, the reagent is little big, but don't worry, it is nothing but the same compound, small extension. Okay, so then the O and the H2 will be removed. What you will get is now a big compound, however, but it is nothing but the continuation of the previous topic. So, you will get a phenyl with the 2-nitro. Here we have one fortunate point is this compound is a orange to red colored precipitate. Previously, all these compounds are white color, but this is a red color precipitate. The reason is even the reagent also will have some orange colored the reagent it is. It is dissolved in the alcohol small quantity, then added to the carbonyl compound. If the compound is a carbonyl compound, either aldehyde or ketone, immediately you will get a red color precipitate. Okay, so that is the importance of this reagent. If the reagent is slightly changed, a small one more change is there. Instead of this, if the reagent is NH2 with NHCONH2, what is the Y here? Y is a urea. Urea containing ammonia, if you take, added to the carbonyl compound like acetone, again this water is removed, it is again a nucleophilic condensation reaction. So, you are getting a compound, once again a big compound, but it is nothing but an extension of the what you have studied previously. So, big compound comes, this is known as, the reagent is known as semi-carbazine, ZINE. Previously used to call carbohydrates, but now it is regularized name is semi-carbazine. What comes here? Semi-carbazone. This is acetone, name of the carbonyl compound, plus added the semi-carbazine, therefore it is known as semi-carbazone. This is once again a white color. Only this 2,4-DNP derivative is the only one is a red color. They are called derived products of this reagent. A, B, C, D, E. 5 reagents are there. Hydroxylamine gives oximes. Hydrogens will give hydrozone. Phenylhydrazine, phenylhydrozone. 2,4-DNP will give a red precipitate called acetone 2,4-dinitrophenylhydrazone. Semi-carbazine with acetone, semi-carbazone. All these 5 compounds will have a very much similarity, except this 2,4-DNP all gives a white color derivatives. They are all used for the identification of aldehydes and ketones, not differentiation. Differentiation, we have some oxidation reactions are there that we will take later. These are all called condensation reactions. Now, let us go for the third type of the reaction, that is oxidation reactions. Oxidation reactions. In the oxidation, the aldehyde group and the ketone group, if you compare, there is some differences there. So, you take an aldehyde and a ketone like acetone and acetaldehyde. The oxidation with a mild oxidizing reagents also, the mild oxidizing reagent also, the nascent oxygen will insert and you will get a corresponding carboxylic acid. Isn't it? These mild oxidizing reagents are, we have A, B, C, different varieties of examples are there, we will illustrate now. The same ABC, if it is added here, no such reaction takes place, because here it is CH is missing here. You have to cut this bond, that is difficult. So therefore, in the first case it is easy for the oxidation, therefore taking place. And what happens, this ABC means they give some the colored the properties here. So therefore, we are going to identify aldehydes from the ketones, right? So what are that ABC? Let us see. The first one is a Tollens reagent. Tollens reagent. The reagent is nothing but you can take a silver nitrate aqueous solution, add some sodium hydroxide, you will get a precipitate, then go on add ammonium hydroxide, you will get the ammonical silver nitrate. Ammonia complexed with the ammonia, silver complexed with the ammonia, a silver amine complex is formed, which is known as, is a clear solution known as what? It is a Tollens reagent known as ammonical silver nitrate. Ammonical silver nitrate, which is known as a Tollens reagent. If this reagent is added to the aldehydes, the aldehydes immediately oxidize. Tollens reagent, if you add, aldehydes will become into the acids. Whereas ketone, if you take no reaction. If the reaction takes place, what is happening? The silver plus 1 is converted into the metallic silver. Silver plus 1 to the 0 means silver is undergoing reduction, the compound aldehyde is undergoing oxidation. So the Tollens reagent is a oxidizing agent, and aldehyde is reducing the Tollens reagent, vice versa in fact. Okay. Similar the case with another reagent called Schiff, that is Fehling's reagent. Fehling's reagent. This reagent also gives the silver and the test tube, you find a beautiful silver deposition on the inner walls will become into a mirror, just like a silver mirror you find here. So therefore, the test is also called silver mirror test. The silver mirror test is given by the aldehydes, but not by the ketones. Ketones no response with this reagent. The Fehling's reagent is, there is A and B, two solutions are there. A is nothing but a aqueous solution of copper sulfate. B is a alkaline solution of sodium potassium tartarate. Sodium potassium tartarate. Tartaric acid is a 4-carbon dicarboxylic acid containing 2,3 dihydroxy. Sodium potassium tartarate plus alkaline medium, basic medium, both if you mix, in the mixture you find a cupric oxide will be there. In the mixture you find a cupric oxide. Copper sulfate with this base, it converts into cupric oxide. When I take aldehyde, the aldehyde is readily oxidized with this cupric oxide and becomes into the cuprous oxide. CuO will become into Cu2O. The aldehyde will become into the acid. CuO will become into Cu2O, which is a red color precipitate. How do you call this? The copper is in the plus 1 state, it is known as cuprous oxide. Cupric oxide is the blue colored one. The blue color, this A and B, if you mix, you will get a cupric oxide, which is a blue colored one, that when you add it to the aldehyde, it becomes into a red color precipitate, namely cuprous oxide is formed. So therefore, ketones, same reaction if you take, no reaction. Ketones under similar, the Fehling's reagent, if you add it, both the Tollens and as well as Fehling's, you need a heating, slightly warm it, no reaction takes place in the case of ketone, but only aldehydes will give this reaction. Okay. There is one more test called Schiff reagent, ABC, Schiff reagent. Schiff's test or Schiff reagent. Schiff reagent is a para-rosanilin. Para-rosanilin is an organic base. It is a organic base containing a pink color. This pink colored one, when I add sulfur dioxide gas, it becomes into colorless solution. It becomes a colorless solution. This colorless solution is known as a Schiff reagent. Schiff reagent. Question may be asked, what is the color of the Schiff reagent? Schiff reagent has no color. How do you got this one? Means taking a para-rosanilin, an organic base which is originally pink color, but past the sulfur dioxide gas it will become colorless. Now you take the aldehyde in one test tube and a ketone in another test tube. For both you add this Schiff reagent. Only aldehydes will become oxidized, therefore the reaction is successful. In this case again this para-rosanilin is regenerated because the aldehydes add with sulfur dioxide, a addition product is formed. The sulfur addition, oxygen addition is an oxidation, therefore aldehydes readily undergoes oxidation. A pink color is restored. Pink color originally was there which is temporarily decolorized with SO2. That reagent if I add to aldehyde, again pink color is formed. Same reaction if you take ketones, no response. That's why in a two flasks, one flask is aldehyde, another flask is ketone. How do you differentiate? Either you add toluenes, you will get a silver mirror. If you add a failings, you will get a red color precipitate. If you add Schiff reagent, you will get a pink color for aldehydes. For ketones, all these three tests will become negative, means no reaction takes place, right? So in all these oxidation reactions, we have one useful the idea, that is differentiating test we are using. However, stronger oxidation leads to the breakage, that is not that important. Now reduction, regarding the reduction we have certain issues. Reduction can be two cases. One can be a mild reduction, mild type of the reduction, or partial reduction. In this reduction, if a aldehyde function like acetaldehyde is taken, okay, example acetaldehyde is taken, you can add a hydrogen nickel, or you can go for the lithium aluminum hydride. This reagents will add 1H here, 1H here, you will get the CH3 CH2OH. Still oxygen is there, but aldehyde has become into the alcohol. Which alcohol is formed? 1 degree alcohol is formed. You can remember that also. All aldehydes corresponding 1 degree alcohols will be formed. If I take a ketone like acetone, acetone is an example for the ketone. The ketone, if you take, what is happening? Similar reaction either with hydrogen nickel or with lithium aluminum hydride. It gives the again an alcohol. The O will become OH. 1H is added to the carbon. So therefore, what is happening is 2 methyls will be as it is. It will become a 2 degree, that is secondary alcohol is formed. Further reduction with these reagents you can't do it. However, we have another type of reagents which will reduce totally the oxygen containing compound into no oxygen containing compound, that is called total reduction. So let us take another type of the reduction, that is called total reduction. The total reduction is also 2-3 types. As I said here, 2 reagents, hydrogen nickel is there, lithium aluminum hydride is also there. Like that, sodium borohydride also you can use, sodium borohydride. Certain reagents are there, either one you can use. For the total reduction also, we have 3 reagents here. One is a name reaction called Clemmensen reduction. The questions are coming on this Clemmensen reduction. Clemmensen reduction, name reaction this is. It is nothing but an aldehyde or a ketone. If you take, for example, acetone I have taken. Okay, acetone has got the 2 methyls and COCH3. When I use this reagent is a concentrated HCl in combination with the zinc mixed with the mercury. Zinc and mercury is known as zinc amalgam. HCl is having speciality concentrated. HCl and zinc reacts, actually zinc chloride and nascent hydrogen will come. But this nascent hydrogen coming is a, we are making little more vigorous by taking concentrated HCl and amalgamated zinc. This reagent is known as Clemmensen's the reagent. When you add this one, the whole oxygen will be removed. In the form of water it is removed. The compound will become into CH3, CH2. That is, in the place of O, we are getting CH2. So what you will get is a propane. Total reduction it is. whereas in the previous case an acetone is becoming to an alcohol where oxygen is still there. Here oxygen is removed totally, isn't it? Same type of the reactions, acetone you take, you will get propane by adding another reagent known as Wolff-Kishner reduction. Wolff-Kishner reduction. Wolff-Kishner reduction. This is also a name reaction, is also asked 1 or 2 times in the different the EAMCET examination. The reagent is, first you have to add the hydrazine to the aldehyde or ketone, both reduces. Ketones and aldehydes both reduces to corresponding alkanes are formed. Hydrazine is added, then followed by a strong base like KOH will be added and heated. Okay. Here you can take some high boiling liquids like glycol or sodium ethoxide is taken and strongly heated. What you will get is propane. Okay. This is also another reagent called Wolff-Kishner reduction. We have another reagent in addition to this 1, 2, we have one more reagent here I am writing on the top. This is also a total reduction with Hi in presence of phosphorus. With Hi and the phosphorus, also the acetone will be converted to propane. All this Clemmensen reagent, Wolff-Kishner reagent and Hi hydroiodic acid in presence of phosphorus is also a strong reducing agent which converts into this type of the reaction. Now we have one base catalyzed condensation reactions. Base catalyzed condensation reactions. Previous condensations are just water removal, but it is now the one aldehyde or one ketone adds on another aldehyde or a ketone and they undergo this type of the condensation, of which one important reaction is aldol condensation. Aldol condensation. This particular one I will take today and go to some discussion of the questions here. In aldol condensation, all carbonyl compounds undergo. There is no limitation for the aldehydes and ketones. The condition here required is both aldehydes and ketones undergo this reaction. But having 2 alpha hydrogens, this is the required one. What is alpha hydrogens means? A carbonyl carbon, if it is there aldehyde, then this first carbon, second carbon is called alpha. Removing the functional group, the first carbon that is attached to the functional group, attached carbon is called alpha or second carbon. This compound should contain 2 alpha hydrogens like this. Acetaldehyde for example, 3 alpha, wonderful. So minimum 2 alpha hydrogens should be there. Both aldehydes and ketones undergo. Second one is a concentrated base is required. For this mostly 50% sodium hydroxide or the potassium hydroxide, sometimes even barium hydroxide is also mentioned in some cases. Okay. So one base should be there and a compound should have 2 alpha hydrogens in the given aldehyde or ketone. So simple examples we will discuss first. A CH3 C double bond OH, isn't it? So this compound reacts with the another the acetaldehyde containing 3 alpha hydrogens. How the reaction takes place, you see, this O and the 2 hydrogens from here is going to removed as I am removing 3 means 2 are removed, still 1 is there. So 2 hydrogens will be removed to get water, still 1 hydrogen will be there. So net product is CH3, CH, a double bond between this and that, and then you write CH and C double bond OH. This is the final compound. Final compound is named as 1, 2, isn't it? 2, it's a bute with all containing ene on the second. So therefore bute 2-ene all is formed, 2-butanol, okay, 2-butene, bute 2-ene, 1-all or aldehyde is formed. This is nothing but they also called as crotonaldehyde. Crotonaldehyde. How the reaction is proceeding means, first of all, 1 hydrogen will be added on the O. So therefore the reaction mechanism, if you see, first the O will take the 1 hydrogen, you will get a CHOH and the rest of the compound will be like this. This is one in between compound is formed, but this hydrogen and OH is eliminating as a water to get this final compound. There are two stages are there. This step is called nucleophilic addition step, addition reaction. This is a minus of water is known as dehydration or elimination of the water. So, one nucleophilic addition followed by the elimination that one alpha hydrogen and the OH is removed, and first alpha hydrogen is added on the O. So, this is nothing but the first alpha hydrogen, second alpha. That is why I am saying 2 alpha hydrogens is mandatory for a carbonyl compound to undergo this type of the reaction. You too can take the acetone also take this reaction. Acetone, if you take, let us take acetone adds with the another acetone, isn't it? A CH3, write CH2CO, CH3. So, in a basic medium it is catalyzed. So, base will take away this hydrogen and gives back. So, let me write this hydrogen is added here, entire minus party adds here. What compound comes means the O will become OH and this methyl, okay, this acetone. Then you write this acetone, CH2 with a C double bond O, CH3. This is the nucleophilic addition reaction is over. Now, the elimination. Elimination is with the OH and one more alpha hydrogen is removed as water. So, 2 acetones are joined with a double bond. So, this is one acetone and this is one acetone joined with this double bond. This type of compounds are called alpha beta unsaturated. Alpha beta unsaturated aldehydes or ketones. Whatever you take, the reaction taking place, but you must have a 2 alpha hydrogen. Let us see some questions on the in this category type, and we will continue this lesson also to the next class because we have some more points to discuss even. So, the first question goes to, this is a 2008 question. Acetone on addition to methyl magnesium bromide, this is an RMGX addition to the carbonyl compound, forms a complex. It is not exactly complex, but it is salt actually, which on decomposition with a acid or acid catalyzed water gives a X, that is an alcohol. This is actually, so alcohol comes and magnesium salt also coming, and which one of the following is the X? Okay, decomposition gives the alcohol. That what is that alcohol? Acetone we have taken, 2 alkyls are already there, 2 methyls are there, another methyl we are adding. So, the compound will have a 3 methyls containing alcohol, that is answer is 2, that is tertiary butyl alcohol is the right answer. Next, an organic compound X on treatment with pyridinium, see pyridinium chlorochromate is known as shortly PCC. PCC stands for pyridinium chlorochromate. In chloro dichloromethane or chloroform gives a compound Y. Compound Y is nothing but an organic compound X is alcohol. Alcohol on treatment with this mild oxidizing reagent gives the carbonyl compound. Carbonyl compound on iodine and alkali haloform reaction is taking place in the chloroform chapter we have seen. Now, this triiodomethane is formed plus the compound is, he is asking the what is X, where from we started, that is an ethyl alcohol is the right answer. Ethyl alcohol will become into the acetaldehyde. Acetaldehyde gives this the iodoform reaction. Next, yeah, which of the product is formed when acetone is reacted with barium hydroxide? As I said, even barium hydroxide can be used as a catalyst. Here we see here acetone is added to acetone. So, acetone and acetone, this type of the beta hydroxy, the carbonyl compound is expected. Answer 1 is the right answer. One acetone is added to the another acetone, right? Answer 1 is the right answer. When acetaldehyde is heated with failing solution, what is failing solution? It is a copper sulfate mixed with the sodium potassium tartarate. So, this solution when it is added, a red precipitate is formed. So, that is because if it is aldehyde, a red precipitate, that is from the cupric oxide is converted to cuprous oxide, that is Cu2O is the right answer. First one is the right answer. Cupric oxide is a blue colored, cuprous oxide is a red colored one, red precipitate is a cuprous oxide. Fifth question. Which of the following compounds is the reactant in Rosenmund's reduction? Rosenmund reduction is a name reaction which is used only on the acid chlorides will convert into the aldehydes. So, what is the reactant means? Starting material, it is the acid chloride. The fourth answer is the one. Acetyl chloride will become into acetaldehyde. It is limited only for the preparation of aldehydes. Rosenmund cannot be used for the ketones preparation. Right? Next. Identify acetaldoxime, acetaldehyde plus hydroxylamine. The reagent is NH2OH. Acetaldehyde, NH2OH, if you add, you will get it. The answer 2 is CH3CH. O should be there. That O and the oxime, the two hydrogens, hydroxylamine, two hydrogens removed. So, second answer is the right answer. Next. 3-hydroxybutanol is formed when X reacts with the Y in dilute Z. So, here you have to write the structure. What is that 3-hydroxybutanol? 3-hydroxybutanol means this is called 3-hydroxybutanol. This is formed in an addition reaction. So, this is one compound, the other one is. So, this was actually acetaldehyde. Acetaldehyde, when added with the another acetaldehyde, the hydrogen is added on the O, this compound is added. So, therefore, you are getting this one. So, therefore, acetaldehyde adds with another acetaldehyde in presence of Z. Z is a sodium hydroxide. So, therefore, two acetaldehydes, one sodium hydroxide combination, that is the fourth answer is the right answer. Next. Which of the following reagents can form a hydrozone with a alkanone? Which of the following reagents can form a hydrozone with a ketone or a alkanone? Hydrozone means a hydrogen should be the reagent, isn't it? This hydrogen is reacting with a ketone and eliminating, the product is known as dash hydrozone. So, therefore, you have to identify which contains that means it is not a ordinary hydrogen, but you have taken a phenyl hydrogen. So, therefore, phenyl hydrogen will on reaction with the carbonyl compound like aldehyde or ketone, corresponding hydrogens will be formed. This will be the last question. So, we will see the next few more questions we will continue in the next class. The question is, an organic compound X gives a red precipitate on heating with the failing solution. Which one of the following reactions yield X as a major product? Once again, a failings reagent he is mentioning. Failings reagent is nothing but the copper sulfate plus alkaline sodium potassium tartrate, and combination you will get a cupric oxide that converts into the cuprous oxide. Cupric oxide is a blue color which reduced to the cuprous oxide, which is a red color precipitate. So, which one of the following he is asking? Heating failing solution you are getting means the acetylene plus water, you get acetaldehyde, that gives this the failings reaction. The last one is acetylene plus water catalyzed by the sulfuric acid, and this one it is a preparation of the acetaldehyde is questioning, and acetaldehyde once it is formed it goes a reaction with this one. Here we will stop discussion. Next day tomorrow we will continue the some more concepts of the aldehydes and ketones, and some more questions we will discuss. Thank you.